Hi everyone. In this video, we're going to be talking about the human memory system. So first, we need to discuss what's called the information processing model. And so the basic idea here is that humans process information the same way that a machine such as a computer would. And remember we mentioned before that sometimes we can't see within the brain to see what's going on, so we have to use metaphors or analogies or operational definitions to kind of figure out what's going on. So that's what we're doing here. We're going to use a computer metaphor to explain how humans process information. So there are three stages of information processing. Number one is called encoding. Encoding is a process of forming a memory trace. So any type of experience that we could be outside, we could be reading a book, we could be riding a bicycle, whatever it may be, all those experiences can be encoded as a memory trace. Now, the way that we do this is that the brain converts these traces into different types of sensory codes. Now, we don't know exactly how the brain does this, but the brain is able to talk to itself in these sensory codes. For example, we could have visual codes. This is where we represent stimuli as pictures. So if you ever close your eyes and form a mental image of something, that would be a visual code. Same thing with a auditory code. Sometimes we can close our eyes and hear a song in our head, or we can hear someone talking to us. That would be an example of an auditory code. So these are the ways that we can process information. Same thing with olfactory codes and so on and so forth. Now, there is one type of code that's going to be very special that we'll talk about later. This is called a semantic code. This is where we represent stimuli in terms of their meaning. So we'll talk about more of this later on in the video. Now, once we encode the information, we have to store it someplace. So up on our cerebral cortex is where we're going to be storing all this information. And so the way the computer analogy works is that on your computer, there are different ways you can encode information. You can type it on a keyboard, you can scan it through a scanner, and so on. Also, we can store it on a hard drive, we can store it on a pen drive, we can store it in the cloud. So that's how the analogy works. And then finally, we have what's called retrieval. This is locating stored information and placing it back into consciousness. Now, as human information processors, we are much, much better at storing information. And in fact, we can store much more information than even the largest, fastest computers can. In fact, many of us can remember things all the way back into our early childhood. Now, the problem that we do have is retrieval, is being able to find that information and bringing it back into conscious awareness. So some of you guys may have had this problem before when you have test anxiety. You study the information, you know it's stored somewhere in your memory, but you just can't find the right retrieval cue to bring it back into memory. Or maybe you see someone at a party, you recognize them, and then you can't remember what their name is. So you have a retrieval problem. And so same thing happens here is that if you write a paper, you save it on your computer, but you can't remember what the name of the file is, you're not going to be able to retrieve it. So what's going to happen then is that any stimulus can act as a retrieval cue. And this will initiate the retrieval process. So for example, if I go to the beach, and when I'm at the beach, I smell the ocean air, that scent can bring back a memory of when I was a child and I went to the beach with my grandparents. Or maybe seeing the pier out in the ocean. Or maybe seeing the ocean waves can bring back the same memory. Maybe the sound of the ocean can also bring back those memories. So any type of stimulus, whether it's olfaction, whether it's touch, whether it's sight, whatever it may be, can bring back those memories. And so that's how the information processing model works. Now, back in the 1960s, Atkinson and Shiffrin actually made up what's called the modal model. This is where they talked about different types of memory stores, how we process information. So we first have sensory memory, then short-term memory, and then long-term memory. So we'll talk about each of these next, and then if we have time, we'll go into a little bit deeper into this information. So sensory memory, this is where we briefly hold information so that the controlled processes of attention and pattern recognition can take place. So obviously we don't store every information that we process. Some information just gets lost. We never even deal with it. So at any moment, you're being bombarded with tons of incoming information. You see things, you hear things, you smell things, you can be tasting things. But we have to decide which of those stimuli we want to store in our memory system. So we have what's called selective attention. We can selectively decide what we want to pay attention to. Now, sometimes we may have the ability to have divided attention. This is where we could do two tasks simultaneously. So maybe as we sit and read a book, we could have background music on the radio. We could do both of those simultaneously. But it would be difficult to watch TV and read a book at the same time because we don't have enough attention to divide between those two tasks. So we can decide what we want to attend to, and sometimes we have problems deciding to attend to the right thing. So even though we're not in classes right now, sometimes when you're sitting in class, you may pay attention to people walking outside, you may pay attention to people next to you, you may pay attention to what's on your cell phone instead of listening to the instructor. So that's what we mean by selective attention. Now, the good thing is that we have a fairly large capacity for sensory memory, but it only lasts for a couple seconds. So if we get distracted just for a brief moment, that information is going to be quickly lost. Next, we have short-term memory. The purpose here is to rehearse information so that it gets stored into long-term memory. Now, there are two ways that we can rehearse information. The first type is called maintenance or rote rehearsal. This is what you learned back in elementary school. This is where you just repeat information over and over and over and over again. This is sometimes referred to as phonemic recycling or verbal repetition. And this is based on what's known as the total time hypothesis, which is the idea that the more that you rehearse it, the more that you repeat it, the more likely you're going to remember it for a later date. So what would happen is that when, say, you're in 3rd or 4th grade, on Monday morning, your teacher would give you a list of vocabulary words that you would have to study for your test on Friday. So every morning, while the teacher is taking roll and lunch count and all that, she asks you guys to say the word, say the definition, say the word, say the definition over and over and over again. And if you did this on Monday, Tuesday, Wednesday, Thursday, then by the time you took the test on Friday, you would actually do pretty well on it. So because of that, you started to think, well, this is the best way to study. Just sit there and memorize. But that's not the way it works. Because this only keeps information long-term memory partly for a short period of time. Because what would happen is that if the teacher gave you the same exact test the following Friday and you didn't go back and rehearse it again, you would probably forget all of it. And this is one of the reasons why students don't like tests that are comprehensive, because you're used to just memorizing information for the exam, and then after that you forget it all. But if it's going to be on a comprehensive final, you have to go back and relearn it all over again. So the better way to study is what's called elaborate rehearsal. This is based on the idea of relating new information to stored information in long-term memory. So the way this would work is this. Instead of saying the words and saying the definitions over and over and over again, what you would do is you would maybe write a sentence using the vocabulary words. Or maybe you would take all 10 vocabulary words and have to write a story using all 10 vocabulary words. Now, in order to do that, you would have to think about what do the words actually mean to write a coherent sentence or to actually make a paragraph that makes sense. And by taking this and using this approach, you actually start to emphasize the meaning of the information, and this is how you can remember it not for the short term, but also for the long term. And so that's why, for example, if you want to increase your vocabulary, the best way to do this is not to study words in a dictionary, but to read books. Because when you read books and you run across a word that you don't understand, you have to think about the context in which the words are being spoken, and then that helps you understand what they actually mean. So anyways, that's how that works. Now, based on this, we have what's known as mass versus distributed study, which is also a problem that a lot of students tend to have. And so what happens here is that a lot of us have been trained to memorize right before the exam. Because you'll tell yourself, well, I can't study today if the exam's not until next week because I'll forget it all by then. And so we're used just to cramming at the last minute, just trying to stuff as much as we can into our memory system, but that's not very effective. Instead, what we need to do is what's called distributed studying. We study a little bit every day. We don't study, 3 or 4 hours at a time, maybe 30 minutes, maybe 45 minutes, but the more that you go back and repeat it, and rehearse it, and look over it, the more likely you're going to remember it for a later date. And the biggest problem that we have in these online classes, if you haven't discovered it yet, is procrastination. And when you start procrastinating and trying to do this mass type of work, it's not going to be very effective at all. So it's a matter of just retraining ourselves. And honestly, Everyone is capable of doing well in school. You guys are all smart. You guys are all intelligent. The only difference between those who get A's and those who get B's are whether or not you actually study the right way. That's the only difference. Now, just to give you an example of a study that shows you how this actually works, the levels of processing theory study was done where subjects would study a list of words. But before each word was given, they would be given a question about that word. And there are three different types of processing. We have structural, phonemic, and semantic. And this refers to the depth or the degree to which we process information. So for example, with structural processing, if I say, is the word in uppercase letters, all you're doing is just looking at the typeface of the word. And so there, you see the word king, is it uppercase, lowercase letters? Boom. You really don't process the word for meaning or anything like that. You're just kind of looking at it. And so this is going to be a very superficial way to study. And in fact, many of us, when you are studying on the couch with the TV on, your eyes can actually track the words in the book, but you're not really paying attention to what you're reading because really you're focusing on what's on TV. And that's why you get to the end of a chapter and not remember anything that you read, even though your eyes tracked all the words all the way through the chapter. Next, we have phonemic recycling. Here, does a word rhyme with ring? Once again, we could ask the word king, show the word king after that, and see if they remember it. This is a little bit better because now we're actually thinking about the sound of the words. And in fact, when we teach kids how to spell, we use what's called phonics, which is the same thing. Write the word out how it sounds. And although this may be a little bit better than superficial processing, the problem is you don't understand the rules of grammar. And that's why a lot of people are not good spellers, because they just try to sound the words out, but the English language is very difficult. And there are certain rules that you have to know, such as I before E except after C, when you spell to get the word spelled correctly. And so that's why semantic processing is going to be the most effective way to do this. If I ask you, is the word a type or relative? Now you have to think about the meaning of the word, and so that should lead to deeper, more effective processing. And when you look at the results, you'll see that when it's structural processing, you're at guess rate. If it's a multiple choice test, it's 1 out of 4, which is 25%, which is just guessing. That's all it is. Phonemic recycling, here what's going to happen is you're going to be a little bit above 50%. So this is, true, false, flip a coin, maybe get it right, maybe you don't. But if you actually study it the right way with semantic processing, now it jumps up to 88%. So now you're getting your A. So what this shows you is the way that you actually study is going to make a huge, huge difference. So it's not based on your intelligence or anything like that. It's just based on the proper study techniques. And unfortunately, you guys were not ever told to study the correct way. And then finally, for capacity, what happens here is that to study the capacity of short-term memory, we give what's called a serial recall test. This is actually how they study it or test it on a intelligence test or an IQ test. And so what happens is that the tester will read off a series of digits to you, and your job is to recall them in the same serial order in which they were presented. And what George Miller in 1956 found out is that the average memory span is only 5 to 9 chunks of information, where a chunk is a meaningful piece of information. So whenever you hear 7 plus or minus 2 chunks of information, that is what's known as your memory capacity. Now, we can increase this by chunking. This is where we group information into meaningful pieces of information, which are called mnemonics. And in the next video, we'll show you how we can actually do this. So anyways, time's almost up, so we'll stop there. And in the next video, we'll talk more about capacity and how we actually study this. If I can just find the turn off key here.